For this example, we've been asked to solve the following system of equations using the augmented matrix. So the first thing I need to do is write down the augmented matrix. Now the augmented matrix is just filled with the coefficients of the x, y, z's and the constant terms. So the augmented matrix for this system of equations would be 1, 2, 1 with a 3, 2, 3, minus 1 with a 4, and 3, 2, 1 with a 6. Now when we're using the augmented matrix, first thing we want to do is get a 0 in the bottom left hand corner. So to get a 0 here, I'm going to say let row 3 be equal to row 3 minus 3 lots of row 1. So we're only affecting the final row, so we still have 1, 2, 1 and 3, we still have 2, 3, minus 1, 4, but now on this final row we have 3 minus 3 lots of 1, which is 0, we have 2 minus 3 lots of 2, which is minus 4, and we have 1 minus 3 lots of 1, which is minus 2, and we have 6 minus 3 lots of 3, which is minus 3. Our next step is to get a 0 in this position here. So to get a 0 here, I'm going to say let row 2 be equal to row 2 minus 2 lots of row 1. And so the first row and the last row remain the same, we're not affecting them. We're only affecting the second row. So what do we get? Well, we get 2 lots of 2 lots of 1. So that gives us 0. We have 3 minus 2 lots of 2, which is minus 1. And we have minus 1 minus 2 lots of 1, which is minus 3. And we have 4 minus 2 lots of 3, which is minus 2. So our next step is to get a 0 in this position here. And to get a 0 here, I'm going to say let row 3 be equal to row 3 minus 4 lots of row 2. So again, the first two rows don't change. So we still have 1, 2, 1, and 3. We still have 0, minus 1, minus 3, minus 2. But now we have 0 minus 0, which is 0. We have minus 4 minus 4 lots of minus 1. So that gives us 0, and we have minus 2 minus 4 lots of minus 3, so that gives us 10, and we have minus 3 minus 4 lots of minus 2, and that gives us 5. So we now have zeros in our 3 positions, so we can just back substitute to get the values of x, y and z. So taking row 3, that gives us that 10z is equal to 5. Therefore we see that z is 1/2. Row 2 tells us that we have minus y minus 3 lots of z is equal to minus 2. So as z is equal to 1/2, we get minus y minus 3 lots of 1/2 is equal to minus 2. Therefore we see that y is equal to 2 minus 3 over 2, which is 1/2. So we've got z equals 1/2 and y is equal to 1/2. Finally, we use row 1 to get the value of x. So we have x plus 2y plus z is equal to 3. So we have x plus 2 lots of 1/2 plus z, which is also 1/2, is equal to 3. So we get that x plus 1 plus 1/2 is equal to 3. Therefore we can see that x is equal to 3 over 2. So we have now solved our system of equations using the augmented matrix. We've got the same answer as what we did previously. We have x is 3 over 2, y is equal to 1/2, and z is also equal to 1/2.